And we're going to head over to connectivities, and we're going to select SPI 1 here, right? My board only have one SPI. Yours may have many, but we're only going to select one SPI here. Then over here, we're going to select the full duplex master. And as soon as we select that, our hardware will be configured already with the clock pin selected, the MISO and the MOSI pins selected. But now we still need to configure the setup for our SPI here. Now here, my parameters are already complaining here. I've got a red here. When I hover over the 2, it says here that please select a new value other than 2 from the provided list, right? So you might not have this problem here depending on the clock frequency of your mainboard here. So to resolve that issue, I'm going to go ahead and change this clock frequency to 16 megahertz as the maximum clock frequency here. That way my APB1 and APB2 peripheral clock will be set to 16 megahertz. That way my SPI is one of the peripheral, and automatically we can see that the 2 here prescaler is no longer being a problem, right? So it's no longer a problem. So but now, because I want to run this at a baud rate of 2 megahertz, I'm going to go ahead and change this to 8 prescaler. That way I'm going to have a baud rate of 2 megahertz. Now the next thing here is to basically just go into the GPIO setting and show that we are running at the maximum clock frequency here. Okay, so when I select here on all my 3 pins here, right, we can see that over here, down here, we've got the maximum speed where you can select low, medium, or high. So we have to ensure that we are running at a high speed, and you can see that the cube STM32 cube IDE already selected a high speed for us. So that basically all we need to do here, so we can go ahead and generate the code for our driver. This means the size of this variable have been increased, but I don't have to change the size of this variable because the size is already the size of this variable. So that's basically what we've done there. We basically one line of code away from completing this driver here. So what I'm going to do here inside my main function here, just right here, I'm going to paste the line of code that will basically call the transmit receive SPI functions, right? Now this is our SPI handled, and these 2 variables are the one that we've defined up here, basically the TX buffer and the RX buffer. They basically data pointers that must be it is connected on D11 and D12. So we basically need to put a jumper wire on D11 and D12 so that we can complete the loop test, right? So I'm going to connect 1, 2, 3, 4 here. So that will be D11, and right there will be D12, just like that. So that basically complete the loop connection, jumping PS6 and P7. Now let's go ahead and test this SPI driver by running it in debug mode. Okay, we can see that there are no data currently into our buffer there, but the transmission data contains data, except that the receiver still got no data. So now let's go ahead and hit on the continue, basically run the program. Okay, and we should be able, once the program is running, we should be able to see the data, the transmission data now available into the receiver buffer, right? As you can see here, we now have the data that are being transmitted here on the transmission buffer, and these data are now available here in our receiver buffer here. Great, so that's basically it for this tutorial. As you can see, we were able to transmit data from our TX buffer into the receiver buffer using the single function transmit receive SPI. So this is a ground setting project, basically tutorial. From here, you can be able to now expand, either interrupt or DMA, or use a master slave transmission, basically using 2 devices. So stay tuned onto CMTEQ channel so that we can explore more tutorial of this nature. Until next time, cheers.